Okay, Chase, this is the video that you requested. Um, my philosophy, like I've told you before in other videos, is I'm going to go fast because you cannot speed me up, but you can always rewind it and slow me down. And so I'd rather go fast and have you back it up than I would go really slow and bore you. So first of all, you mentioned on the sheet of paper that you handed me, you said this. Let me change this size real quick, make this a little less big since we're not in class. Okay, you mentioned to me page 349, and you can look that up if you want to while I'm writing this. You wrote down page 349, and I'm trying to find it right now, numbers 68 through 84. Now, every other even. Now, if you're trying to get the 5 bonus points for your test, that means you have to do these. I will let you do the odds if you would like. That's fine with me. I don't mind that. And the reason I'm saying that is I'm not going to give you a video for these at all. Instead, if you will go to YouTube and type this in perfectly, just like this, Berean space, Academy space, Algebra space, 2 space, February space, 18th, up will pop the video that does this page here, only it does numbers 69 through 85, the odds. And so if you want to do those in place of these, I will accept that. And obviously they're the exact same kind of problem. So there you go. So you might end up watching 2 videos. Okay, so I'm not going to do any of these for you. Instead, go to YouTube, type this in just like it is, watch that video, and that will take care of your questions you had on page 349, 68 through 84. Okay, let's continue on. Now, one of the things you asked for me to look at was page 356, number 15. Number 15. So 356, number 15. Let's see if we can't help you a little bit with that. Okay, divide using polynomial long division. Okay, and if you'll look in your book and see the problem, it's not quite written in this form, but see if this makes sense. The first parentheses, because they say to use long division, the first parentheses will go inside the division box. We call that the dividend. And the second parentheses will go on the outside. We call that the divisor. Okay, there we go. Now what I've taught you to do is always write this in standard form, and it's already done for you, and always write this in standard form, and it's already done for you. What you do next is you always divide the first term into the first term. Okay, so how many times does x go into x squared? Or in other words, look at it like this, Chase. What can I write up here so when I multiply it times this, it'll give me x squared? Well, obviously I'm going to write an x here because x times x is x squared. But then also you must take x times negative 2, which gives you negative 2x. Notice how I'm lining up my like terms, okay? That's very important. I'll be doing another one for you here in a little bit, and you'll see how you always have to line up your like terms. Now what I've taught you next to do is change your signs and add. So I make this negative, I make this positive, these cancel, and now I'm left with 9x minus 5. Bring down your negative 5. Now you divide first term into first term, but another way to say that is simply this. What would I have to put up here so when I took this times x, I would get 9x? Well, obviously it's going to be 9 because 9 times x is 9x. And then also multiply 9 times negative 2, that's negative 18. Now change your signs, combine, and we'll get 13. Now x cannot go into 13, okay? So I'm finished. That's my remainder. So I put plus, there's my remainder, over my divisor, and my divisor is x minus 2. All right? I hope that helps. All right, let's try another one. You also mentioned on the same page number 21. So let's take a look at number 21. Now number 21 has a divisor of x squared minus 1, and it has a dividend of 2x to the 4th plus 7. Now notice when I say plus 7, Chase, notice we're missing a lot of terms here. Usually there would be an x to the 3rd, x squared, etc., etc. Now I don't know if we're going to need all of those, so I'm not going to write all those, but I am going to put my plus 7 way over here. It's kind of a smart thing to do, okay? All right, now I'm going to divide first term into first term. Or in other words, what would I write up here? So when I multiply this times this, I get 2x to the fourth. Well, I know I need a 2 for sure. And then how about an x squared? Because 2x squared times x squared would be 2x to the fourth. And 2x squared times negative 1 would be negative 2x squared. Now notice I have like terms right here, okay, x to the fourth and x to the fourth, but I do not have like terms here. So I just wrote the negative 2x squared right here, change the signs, and add. These will cancel, bring down the 2x squared. Now I might need to bring down the 7, I might not. Let's wait and see. I am now going to divide first term into first term. So in other words, what would I put right here in this imaginary circle that when I multiplied it times x squared, I would get 2x squared? Well, a positive 2, because 2 times x squared is 2x squared, and 2 times negative 1 is negative 2. So I am going to bring down my 7 because it matches. And now I've taught you to change your signs and add. Make that negative, make that positive, those cancel, and you're left over with 9. X squared cannot go into 9, so I put plus, and then I put my remainder over my divisor, which is x squared minus 1. And this whole thing is your answer. Okay, let's see what else you asked me to work out for you. You mentioned number 23. Let's take a look at number 23. Let me get a quick drink of water here. Okay. All right, moving on to number 23. Your divisor, Chase, is 2x plus 3. And your dividend would be 6x squared plus x minus 7. All right, here we go. How many times does 2x go into 6x squared? Well, I mean, what would I put up here when I multiply by 2x, give me 6x squared? I know I need a 3, and I know I need an x, because 3x times 2x would give me 6x squared, and 3x times 3 gives me a 9x. There we go. Change your signs. That becomes negative, this becomes negative, and we add. You would get negative 8x. Now, divide your first term and your first term. What number would I have to put here? So when I multiply it by 2x, I get negative 8x. Well, probably a negative 4, because negative 4 times 2x is negative 8x, and negative 4 times 3 is negative 12. Now we change our signs. Those cancel, and I'm left with 5. So my remainder is 5. So plus 5 over 2x plus 3. Okay? All right, let's move on to number 20, number 51 actually. You had a question on. Okay, number 51, they give you one of the zeros, okay? Now here's your function. If you'll look in your book, we're on page 357, number 51. Now here's your function, x to the third power minus 14x squared plus 47x minus 18. Now they give you one of the zeros. So Chase, when they give you one of the zeros, and if you'll look in the book, you'll see they have a semicolon here and the number 9, I believe. And what they're saying is 9 is one of the zeros. Now if you look at the directions, it says given one of the zeros, find the other zero. So if we know this is one of our zeros, let's go ahead and put a 9 like this. Let's use synthetic division. 1, negative 14. By the way, don't forget to put zeros in if you're missing any terms. We're not, but always be sure and check that. Okay. We should get out a 0 right here. Let's see if we do. Bring down your 1. We multiply 9 times 1. That's 9. We combine these two. We get a negative 5. We multiply 9 times negative 5. We get a negative 45. We combine these. We get a 2. We multiply 9 times 2. That gives me positive 18. We combine these two and we get a 0. Now remember what that means. Remember this 1 right here? It was a 1 what? It was a 1 x cubed, right? X cubed. So we always go 1 less than that. So we're going to have 1x squared minus 5x plus 2. Now you know what, Chase? I wish I could factor this, because if I could, it'd be a lot easier to find the zeros, okay? But I cannot factor this. This is one of the easy trinomials. Remember why? It has a lead coefficient of 1, okay? Now whenever we have a lead coefficient of 1, That's the easy kind of factoring. We just say to ourselves, what two numbers multiplied together give me 2, but when add together give me -5. Well, unfortunately, there are no numbers like that, okay? So let's continue on, and let me show you what we're going to have to do. I wish we could factor it. We just can't do that, okay? We cannot factor it. So we're going to take this expression right here. And remember, Chase, we already know 1, 0 is what? Remember, they gave that to us, 9. Well, this is a quadratic. And whenever you have a quadratic, you can use the quadratic formula, which is -b plus minus the square root of b squared minus 4ac all over 2a. Now, you better write this down because I'm going to erase it in about 3 seconds. So why don't you pause the video and copy this down because I'm going to go ahead and erase it right now. But that's the quadratic formula, all right? So a is 1, b is -5, excuse me, and c is 7. So I can use whenever I can't factor a quadnomial, I can use the quadratic formula on it to find the 0. So -b, I'm putting a -5 in, so negative would be a +5, plus minus the square root of b squared. So -5 squared would be a +25. And then I have a -4ac, so I've got to take -4 times a times c. So let's go ahead and do that. -4 times 1 is -4 times 7 is -28. So I get a -28 all over 2a. 2. So really, there's not a lot I can do here, Chase. To simplify, it's going to be 5 plus minus the square root of -3 all over 2. You see where the -3 came from? 25 minus 28. Okay? So the only thing I can do is this. I can make this a +3, and I can put an I right here. So there's your zeros. 1, 0 is 9, then a comma, and here's your other 0 right here. And I know it looks weird, but that's good enough for me. You're more than welcome to leave it in radical form. That's fine. Okay, moving on. Moving on to number 53. And I hope all this is a help to you. If it's not, I'm sorry, but this is the best I can do to help you here. Chase, I'm not going to copy the problem out of the book. Your book should be open to page 357, and you can see number 53 right in front of you. So I'm going to go ahead and say this. One of the zeros is -3. They give that to you. Do you see that? Look in the book, and you'll see that. And then, of course, we're not missing any terms. If we were, we'd put a 0 in, but we have 1, 1, 2, and 24. Now, remember, they told us -3 is a 0, so we should get a 0 out here. All right, let's bring down our 1. We get a 1. Let's multiply. We get a -3. Combine these two. You get a -2. Multiply -3 times -2. That's +6. Combine these two. That's an 8. And -3 times 8 is -24. Okay, so good. So what was this 1? Was it not 1x cubed? If you'll look in the book, you'll see it's 1x cubed. So we go 1 less than that. It's going to be 1x squared minus 2x plus 8. And Chase, again, this is unfactorable. This cannot be factored. Let me explain why. Here's the reason why, Chase. Notice I have a lead coefficient of 1, so I say to myself, what two numbers multiplied together would give me 8, when added together give me -2. Well, Chase, you're not going to find any, okay? I mean, 8 times 1 is not going to give you 2. 4 times 2, you're thinking, oh, 4 times 2 might work. Well, it's got to be a +4 times a +2, or a -4 times a -2. If you multiply these, you get 8. If you multiply these, you get 8. But if you combine those and add those up, you will not get -2. So this cannot be factored. So unfortunately, which no one loves this, but now we're back to the quadratic formula again. And I don't mind doing that for you. I'm just saying that's what we're going to have to do. So, all right, here we go. Well, a equals, let's write this down, a equals 1, b equals -2, and c equals 8. All right, -b, that's -2, so a +2, plus minus the square root of b squared. Well, that'd be -2 squared, that's 4. And then we have minus 4ac, so we're going to have to multiply -4 times a times c. So let's see what we get. -4 times 1 is -4, times 8 is -32. So -32. All over 2 times 1, 2a, which is 2. Now this one will be a little more complex, Chase. We have I'm not sure why I put negative 2. Hold on a second. We have 2 plus minus the square root of negative 28 all over 2. Now let me show you why this is a little more complex. First of all, you should know to make this positive and put an I outside the radical. Number 2, you should also know by now that 28 can be broken down into a perfect square, 4 times 7. Do you see that okay? 4 times 7 is 28. And now you can take the square root of 4 right here and put a 2 on the outside. So now you would have 2 plus minus 2 square root of 7 with an I all over 2. Now please look at your 3 outside numbers, Chase. 2, 2, and a 2. Now look, I want to show you something that's very important, okay? If you can reduce all of your outside numbers, that's fine. Now if this had been a 3, right here, a lot of students want to try to cancel their 2 and their 2, and you cannot do that because all 3 outside numbers have to be divisible, okay? And so I have a 2, a 2, and a 2. All 3 numbers are divisible. 2 goes into all of them, so this will become a 1, this will become a 1, and this will become a 1. So let me go ahead and cut and paste this and send this to another page. So if you reduce that, you would then have 1 plus minus 1 square root of 7 I all over 1. Now anything over 1, you know that like 2 over 1 is the same thing as 2. You don't have to put that 1 in the bottom. So since I don't need the 1 in the bottom, I'm just going to not use it. I'm going to say 1 plus minus 1 square root of 7 I. So there's a couple zeros for you. And then don't forget they gave us one of the zeros way back here. Remember right here they told us negative 3 was one of the zeros and it gave us out a 0 right here. Remember that? So we know also one of the zeros is negative 3. So negative 3. So there's your zeros, okay? Also, you asked me to work out a problem, graph this. Now, this is going to take a lot of work, but I need you to be patient and kind of follow along here, okay? Anytime you're asked to graph a polynomial function, you want to find the zeros, okay? Now, zeros are the same thing as the x-intercepts, and you want to be able to find those. And the first thing you want to always try to do is factor. Now this is a 4-term polynomial expression, 1, 2, 3, 4. And what I've taught you to do, Chase, is to pull out what's common in the first 2 and pull out what's common in the second 2. And when you do that, your parentheses should match, okay? If you tried that in this problem, your parentheses would not match. Thus, this is not factorable. And the one I gave you on the test, I made sure you could not factor because I want you to find zeros on your own by listing out the possible rational zeros. So the first thing you're going to do is you must list out the possible rational zeros. So there's a 1 here. If we list out all the factors of 1, that's 1 times 1, or just 1. If I list out all the factors of 12, I would have 1, 12, 2, 6, 3, 4. All of those are factors of 12. And now I want to list out all my possible rational zeros, so I put each one of these numbers here on top of each one of these numbers over here, okay? So 1 over 1 would be 1, 12 over 1 would be 12, 2 over 1 would be 2, 6 over 1 would be 6, 3 over 1 would be 3, and 4 over 1 would be 4. All right, so these are the numbers I have to test until I find a 0, okay? Now it is going to be a little time consuming, but we need to test each one until we find one. Now sometimes you'll get lucky and sometimes you won't. I'm going to start off testing a positive 1 right here. Okay, so here's my list of possible, well actually what I'm going to do is I'm going to go ahead and test 1, positive 1. I'm just going to start checking until I find one. So I'm going to go ahead and cut and paste this to the next page. And let's go ahead and see if 1 is a 0. Put a 1 there. Let's use synthetic division, and let's see if we get out a 0. Now if I'm right, if 1's a 0, I should get a 0 right here. Okay, bring down your 1. Multiply, we get a 1. Combine, we get a negative 1. Multiply, we get a negative 1. Combine, we get a negative 12. Multiply, we get a negative 12. Combine, we get a 0. That's good, okay? So 1 is a 0, so that's one of your zeros. Don't forget that, okay? That is one of your zeros. So this 1 right here was an x cubed. Do you see that? 1x cubed. And so I'm going to go one less than that. I'm going to go 1x squared minus 1x minus 12. Now maybe I can factor this. And you know what? I can. That's what's so cool about this. What two numbers multiplied together give me a negative 12? When added together give me a negative 1. Well, I think of these two numbers right here. Negative 4 times 3 is a negative 12. And when you combine these two, you get a negative 1. So the factorization would be x minus 4, x plus 3. Now, we have been over this. Don't forget, I keep saying this over and over. This is one of our zeros right up here. We found a number that gave us out a 0, okay? Now, if I'm looking for zeros, I want to take each one of these groups right here. Let's get a new page up here. I want to take each one of my groups and set each group equal to 0. And this will give me the zeros. So, one 0 is 4. The other 0 is 3. Or excuse me, negative 3. Now, Chase, that means I know my zeros are, what I say, 1, 4, negative 3. So if I've lost you, go back and rewind it, watch this again, whatever you got to do to get it, okay? But I'm just saying to you, we should be okay with this. We found the zeros. Now don't forget, zeros are the same thing as x-intercepts, okay? So I will, let's see, let's go ahead and put a new page up here. And what I want to do next, Chase, is I want to fill in a table of values, okay? Wow, that's really good. Let's try that again. There we go. Now I'm going to put really thin or small tick marks here because I want to get a lot of numbers on here, okay? Now think of a number line, Chase, would you please? Our zeros are 1, 4, and negative 3. So think of a number line. Here's 0, here's 1, here's 4, here's negative 3. Think of a number line, okay? We want to test numbers, or we want to put numbers into our table of values that go outside our zeros, and these are our zeros right here, okay? This number line, Mr. Erhart, why you give me a number line? Because I want to show you, Chase, what x values you're going to use over here, okay? You got to know what x values you're going to put into your table of values, and this number line will help you see it. For example, let's start over here. Negative 3. Well, let's go out here about 3. So negative 4, negative 5, negative 6. So I know I'm going to put a negative 6, a negative 5, a negative 4, then a negative 3. Now we know what negative 3 gives me out already. Remember, negative 3 is a 0, so I know negative 3 gives me out a 0. Let's continue on. My next 0 is 1. Well, I'm at negative 3. We can put a negative 2. We can put a negative 1. We can put a 0, and then a 1. Now we know 1 is going to give me out a 0. And then keep working our way along here. I know I can put in a 2 and a 3 and a 4. We know 4 is going to give me out a 0. And really, I ran out of room, Chase. You really should put a 5 and a 6 and maybe even a 7, okay? Now, I've been really, I'm not trying to brag, but I've been gracious to do this, and I'm glad to do it. I will do it as many times as you need me to, as long as you're working hard. But I don't have a grapher with me in front of you. But Chase, what you can do now, excuse me, is you can type this into your grapher right here. Type this into your grapher perfectly. I'll type it in perfectly right. And then hit table of values, and all of these table of values will pop up for you. I'll try to give you a couple real quick here, but I'm going to have to cut and paste this on the other screen so I can see it and use it. So let me do this and this. And let's see if we can't. I think that's going to slide more than what I want. Yeah, it's not going to work. Okay. Well, that's fine. We can still see, for the most part, the function. All right, here we go. So, you can go ahead and type this into your grapher. I don't have one with me. But I can do a couple of these quickly in my head. I think that's a positive 12. Yeah, positive 12. So this is a positive 12. So We'll try a negative 4 real quick. That would be 4 times 4 would be a negative 64. 16 be a negative 32. Negative 44. That's going to be pretty high. Negative 100, 130. So negative 4 is going to shoot way down low, like a negative 130 something. I'm just guessing, something like that. So I can only imagine these will get bigger. Negative numbers getting bigger and bigger. Now negative 2 should give you out something like a negative 8, negative 8, a 22, and a 12, which would be a 34. You should get out about an 18 right here, I'm guessing, something like that. And then for negative 1, you get out a negative 1, a negative 2, a positive 11, a positive 12. That's 23, minus about a positive 20 approximately. 0 would give you out a 12. And then 2 would give you out a 8, minus 8, negative 22, and 12 would be a negative 10. And then 3 would probably give you out 27, negative 18, negative 33, positive 12, and that would be what? Negative 41 and positive 39. So I'm thinking a negative 2, but I could be wrong. But I'm estimating those, but you'll see. You say, well, Mr. Erhart, why'd you do all that? Because I want to put a graph up here real quick for you. I want you to see the graph. And so what I want you to do now in your notes is you go ahead and draw your coordinate plane. And obviously, Chase, you're not going to need to plot the ones that are negative 130 or whatever, all those really big numbers. All right, so I'm going to go ahead and plot my zeros first, my x-intercepts. We know negative 3 gives me out a 0, 1 gives me out a 0, and 4 gives me out a 0. Now let's go ahead and start. We know negative 6, negative 5, and negative 4 give me some negative numbers way down here. So I know the graph's going to shoot way down like that. Now at negative 2, let's see what negative 2 would give us. Looks like negative 2 gives us out at 18, so it's up here somewhere. So it shoots up pretty, pretty high. Pretty high up here at negative 2. And then at negative 1, it goes even a little higher. So we're just kind of estimating, Chase. I'm not trying to really be that picky about it. And then at 0, it kind of comes back down at 12. So I guess we're kind of saying some increments of 2 maybe. And then at 1, it would hit a 0 here. And then at 2, it goes to negative 10, so it'd be down here somewhere. So sorry about that, Chase. I'm not sure why it keeps doing that. And then at 3, it's at negative 2, so it hits there, then starts to go back up, and continues going back up. And my graph's not perfect, not even close to being perfect, but we're just trying to sketch. That's all we're doing. Just getting a main idea of what it looks like. And then I'm not sure what 5 and 6 would give you. I'm assuming they'll give you out some really big positive numbers. So it's your job to go back, Chase, and rewind this 100 times if you have to, okay? But I still want to review anyways, okay? So whenever you're given a problem like this and I give you one word, graph, the first thing you want to do is find the zeros. Now, if you can factor this original problem and find the zeros, more power to you. But I made sure the one I gave you in the test you could not factor. So if you can't factor it, then you list out the possible rational zeros. Then you start checking each one by one until you found a 0. Well, we found a 0 right off the bat. It was 1. 1 gave me out a 0. And so because 1 gave me out a 0, I then had this left over right here. And I could rewrite that like this, and then factor that, and I knew my zeros were then 1, 4, and negative 3. Now, I knew those were also the x-intercepts. So remember the number line example I gave you? I said you'll know what to put in for your x values over here, all of these x values. you'll know what to put in if you just kind of use a number line. And remember, okay, my zeros were -3, and then 1, and then 4. So I started over here. I put in 3 numbers to the left. Then I filled in numbers in between the zeros, and I went 3 numbers past the 4, and that gave me all of my x values. And then your calculator will do the rest of the work for you. And then you sketch the graph, okay? I'm going to shoot you off an email now telling you, when the video is going to be up and running and what the name of the video is. And again, word problems. Chase, there's no word problems on this test. Now, I'm not, perturbed that you didn't know that. I'm just telling you, I'm not sure, what you were getting it confused with. But on this test, there were no word problems. Now, the quadratic test, that's chapter 5. I don't think you've turned that test in yet either. But on that test, there's word problems. But I've already given you the word problems, and we went over those in class. There were 3, and we practiced and practiced and practiced those. So I don't think you were talking about those. But there are no word problems on the chapter 6 test, okay? That's it. Have a good day, night, whatever, and we will see you on Monday.